We're going to look at the series today where we're taking 1 plus 1 over n to the nth power. And what we're going to do is we're pretty sure this is going to diverge. So we're going to be using the test for divergence, and we're going to work with that to show that it diverges. And I'm going to use div for a shorthand for divergence. Remember, one of the things that we can do, and this is for the divergence test, is we take the limit as n goes to infinity of our interior of our sum. So this is 1 plus 1 over n to the nth power. And you'll notice in here we got two things that are competing against each other. We've got this 1 over n that is going to 0, and we've got this exponent n that is making things larger. So those are going to be competing against each other. And in particular, that exponent n is a problem when we try and take a limit. What's going to happen with that? So because that issue is a problem, what we are going to do is get rid of the problem in the best way that we know how, which is to hit it with an e natural log. Now, when you do this, you're not actually changing your problem. You see, we still have the equality there because e and natural log cancel each other out. So it's okay to, as long as we put both of them in, we're good to go. Once we have that, let's move our natural log inside the limit, which is one of those lovely things that we can do. And now that we have it inside the limit, our natural log laws say that if we have natural log of x to the yth power, we can write this as y natural log of x. So this is a nice thing to remember when we're working with these types of problems. If you like tips and hints like this, subscribe. I'll be doing Calc 2 problems all spring. All right. So now that we have this, let's rewrite this. Our n is out front, natural log of 1 plus 1 over n. And I'm going to rewrite it one more time because as we look at this right now, this bit right here, notice our n is going to infinity, and our natural log of 1 plus 1 over n, this is going to natural log of 1, which is going to 0. So basically you have this infinity and the 0 competing, and we're trying to figure out which one of these two is actually going to win. So that's basically infinity times 0, which tell us something. And I'm going to rewrite this so that we have something that might be a little bit more something that you're used to seeing. I'm going to throw that n in the denominator just so that it looks a little prettier. And so now what we see is if we took our limit to go to infinity, we'd get natural log of 1 over 0, which would be 0 over 0, which means we have a setup for L'Hopital's rule, which is fantastic because that is exactly what we want to do. So we're going to L-hop this. And we're just going to write NLH on there to let everybody know we are taking L'Hopital's rule. Derivative of the top divided by the derivative of the bottom. On the numerator, we're going to get 1 over 1 plus 1 over n times the derivative of the interior. This is a chain rule. And so we also need, and I'm going to do this on the side, we also need d dx of 1 plus 1 over n. And notice our 1 is going to disappear. That's just a constant. The 1 over n can be rewritten as 1 plus n to the negative 1. And we take our power down, subtract 1 to make our new power. So this is negative 1 over n squared. And that's our derivative. So negative 1 over n squared. We can use that information to get our denominator here as well. The derivative of 1 over n is negative 1 over n squared. Now we have the same thing on the top as the bottom. So those two are going to cancel. And we're going to go to the next page here. At that point, we have e to the limit as n goes to infinity of 1 over 1 plus 1 over n left over. That's all that's left. 1 over n goes to 0 as n goes to infinity. So we get and end up with the limit e to the first power, actually, because 1 over 1 is 1, which is the lovely number e. And in particular, what we know about e is it's 2 point something, which is non-zero. So our series is divergent by the divergence test. And your teacher may want you to actually talk about which test you're using, so it's a good idea to put that on the page. Thank you so much for listening.